Hello everyone, welcome back to our YouTube channel. I am Rachana. In today's video, we are going to learn 10th grade syllabus mathematics. In this video, we are going to understand chapter 1, that is arithmetic progression. In upcoming following videos, you are going to learn about other chapters in the 10th standard grade syllabus package. So ensure you subscribe so you don't miss out any important updates. Let's begin with the session. Today's session is all about arithmetic progression, and today we will be learning about what is an arithmetic progression, what is the term in an arithmetic progression, formulas in arithmetic progression, best possible ways to finding arithmetic progression, and nth term of an arithmetic progression, and the sum of n terms of an arithmetic progression. So what is an arithmetic progression? An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called the common difference of the arithmetic progression. Remember, fixed number can be positive, negative, or a zero. So what is a term? In this picture, 1, 2, 3, 4, 100, 70, 40, and 10. So each of these numbers in the list is called a term. 1 is a term, 2 is a term, and 100 is also a term. So let's begin with solving the questions in the arithmetic progression chapter. And the question number 1 is, for the arithmetic progression 3, 1, -1, -3, write the first term A and the common difference D. Here, A will be 3 and D will be 1 -3 is equals to -1. D can be found using any two consecutive numbers or any two consecutive terms once we know that numbers are in arithmetic progression. So the answer will be -1. So the next question is, find the 10th term of the arithmetic progression 2, 7, and 12. So here A will be 2 and D will be 7 minus 2, that is 5, and N will be 10 as mentioned in the question, that is 10th term of the arithmetic progression. So the formula to find the nth term of an arithmetic progression is An is equals to A plus N minus 1 D. So A10 will be 2 plus 10 minus 1 into 5. 2 plus 45, that is 8, 10 will be 47. So, therefore, the 10th term in an AP will be 47. Now let's move to the question number 3. Which term of the arithmetic progression 21, 18, 15 is minus 81? Also, is any term 0? Give reason for your answer. So now let's see which term in an arithmetic progression is minus 81 and if there is any zeros in any term. So here A is 21 and D will be 18 minus 21, that is minus 3, and AN, as mentioned in the question, it is minus 81. So we have to find N. Let's put the formula. AN is equals to A plus N1 minus D. So AN we have minus 81. A will be 21. N minus 1 and D will be minus 3. Minus 81 is equals to 21 plus minus 3 into n, it will be minus 3n, minus into minus it will be plus, and 3 into 1 will be 3. So minus 81 is equals to 24 minus 3n minus 105 is equals to minus 3n. N will be 105 divided by 3, that is n is equals to 35. So therefore 35th term is minus 81. So therefore we found that 35th term of the AP is minus 81. So next we want to know if there is any zero in the terms. That will be, let's proceed it with the formula, that is AN is equals to A plus N1 minus D. We already know A is 21 plus N minus 1 and D will be minus 3. Three N minus 1 is equals to 21. So N will become 8. So the 8th term in an AP is 0. Now let's move to the fourth question, that is determine the arithmetic progression whose third term is 5 and the seventh term is 9. So now let's determine third term is 5 and the seventh term is 9. We have A3 is equals to A plus 3 1 minus D, and A7 is equals to A plus 7 minus 1D, which will be A plus 2D is equals to 5 and A plus 6D is equals to now. We have two equations now. Let's solve this both linear equation, that is let's solve this linear equation 1 and 2, that is A plus 2D is equals to 5 and A plus 6D is equals to 9. Minus. So D will be 1 and let's find out the A, that using one of the linear equation, that is A plus 2D is equals to 5. A plus 2, that we have D as 1 and 5. A plus A will be 5 minus 2, that is A will be 3. So we have A and 3, that is A and D, that is A will be 3 and D will be 1. So hence the required AP is 3, 4, 5, 6 and 7. Now let's move into fifth question, that is check whether 301 is a term of the list of numbers, that is 5, 11, 17 and 23. So now let's check whether 301 is a term in the given list of numbers, that is 5, 11, 17 and 23. So we have A2 minus A1, that is 11 minus 5 will be 6, and A3 minus A2, that is 17 minus 11 will be 6, and A4 minus A3, that is 23 minus 17 will also be 6. Hence, it has the common difference. The given list of numbers, that is 5, 11, 17 and 23, is an arithmetic progression. Now, A will be 5 and D will be 6. Let's assume 301 be a term in the given list. Let's say the nth term in an AP. We know the formula to find the nth term, that is an will be a plus n minus 1 d. So we have assumed that 301 be nth term. So let's substitute in the formula 301 5 n minus 1 and d will be 6. So 301 will be 6n minus 1 and then will be 301 by 6, which will come to 151 by 3. So we know that nth term should be always an integer. Hence, n, that is 301, nth term 301 doesn't have any integer. So 301 is not a term in the above mentioned list of number. So the next question is, how many two-digit numbers are divisible by 3? So now let's see how many two-digit numbers are divisible by 3. So the list of two-digit numbers that is divisible by 3 are 12, 15, 18, and so on till 99. So let's see, is this an arithmetic progression? Let's say A will be 12 and D will be 15 minus 12, that is 3, and AN will be 99. Let's put this in the formula, that is AN will be A plus N minus 1 D. AN is 99, A is 12, N minus 1, D will be 3. It will be 87 is equals to N minus 1 into 3. And N minus 1 will be 87 by 3, which is 29. And N will be 29 plus 1, that is 30. So therefore, there are 32 digit numbers that are divisible by 3. So now let's see the seventh question. A sum of 1000 rupees is invested at 8% simple interest per year, calculate the interest at the end of each year. Does do these interests form an arithmetic progression? If so, find the interest at the end of 30 years, making use of this fact. So the sum of 1000 rupees is invested at 8% simple interest per year. Let's calculate the simple interest for the first year. So we all know the formula for simple interest is P into R into T by 100. So the interest at the end of first year will be principal is 1000 and interest rate is 8 and the time period is 1 divided by 100. It will be rupees 80. Let's calculate this simple interest for next 2 years. Interest for second year will be 1000 into 8 into 200. It will be 160. And for the third year, it will be 1000 into 8 into 3 divided by 100, which will be 240. Similarly, we can obtain the interest at the end of the fourth year, fifth year, and so on. So the interest at the end of the first, second, and third years respectively are 80, 160, and 240. So let's find out whether these numbers are a list of arithmetic progression or not. A will be 80 and D will be 160 minus 80, which is 80. And if we see for the next term, that is 240 minus 160, this will also be 80. So it is an arithmetic progression as the difference between two consecutive terms in the list are 80. So let's find out the interest at the end of 30 years. Let's find A30. A plus 30 minus 1 and D will be 80. It will be 29 into 80. So A30 will be 2400. So the interest, therefore, the interest at the end of 30 years will be rupees 2,400. So now let's see the next question. In a flower bed, there are 23 rose plants in the first row, 21 in the second, 19 in the third, and so on. There are 5 rose plants in the last row. How many rows are there in the flower bed? So let's find out how many rows are there in the flower bed. The number of rose plants in the first, second, and third rows are 23, 21, 19, and so on. And the last row, there is 5 plants. Now let's find out whether it is an arithmetic progression, whether it forms an arithmetic progression. Let the number of rows in the flower bed be n. So A will be 23 and D will be 21 minus 23, that is minus 2, and AN will be 5. So AN is equals to A plus N1 minus D. 5 is equals to 23 plus N1 minus 1 minus 2, which will be minus 18, is equals to n minus 1 and minus 2. And at the end, n will be 10. So therefore, there are 10 rows in the flower bed. So the next question is, find the sum of the first 22 terms of the arithmetic progression. And the terms are 8, 3, minus 2, and so on. Here, A will be 8 and D will be 3 minus 8, which is minus 5, and N will be 22 as mentioned in the question. The formula to find sum of the first terms are S is equals to N by 2, 2A plus N1 minus N minus 1 into D. Let's substitute our values in the formula. S is equals to 22 divided by 2, two into 8 plus 22 minus 1, and D will be minus 5, which will be 22 divided by 2. 2 into 8 will be 16, and 22 minus 1 will be 21. and minus 5 will be the same. Is equals to 11. 22 divided by 2 will be 11. And 16 minus 105. 21 into minus 5 will be minus 105, which will be 11 minus 81. So the 11 into 81 will be minus 979. Therefore, sum of first 22 terms is minus 979. So the next question is, if the sum of the first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. So now let's find the 20th term in the arithmetic progression, where we have sum of 14 terms, that is 1050. So S14 will be 1050 and N will be 14 and A will be 10. And the formula to find the sum of the terms are Sn is equals to N by 2 into 2A plus N minus 1 into D. So Sn we already know, that is sum of 14 terms is 1050 and N will be 14 and A will be 10. N will be 14 minus 1 and D will be the same. 1050 is equals to 14 by 2, 20 plus 14 minus 1 will be 13. 13 into D will be 13D. Zero 50 is equals to 140 plus 91D. Therefore, 910 will be is equals to 91D. 1050 minus 140 will be 910 and 91D will be the same. So the D value will be 910 divided by 91, which is D is equals to 10. So now we have found the value for D. Let's find the 20th term of the arithmetic progression. That is A20 will be A plus N minus 1 into D. That is A will be 10 plus N will be 20 minus 1 and D will be 10. That will be 10 plus 20 minus 1 will be 19 into 10. It will be 10 plus 190, that is 200. So therefore, 20th term of an arithmetic progression is 200. The sum of 20th term is 200. So the next question is, how many terms of the arithmetic progression 24, 21, 18 and so on must be taken so that their sum is 78? Given A is 24 and D will be 21 minus 24, that is minus 3, and Sn is 78. We need to find what is n. So the formula for sum of the first terms, n terms, are Sn will be n by 2, 2a plus n minus 1 into d. Sn we already know, that is 78. N by 2, 2 into a is 24 plus n minus 1 and d is minus 3. $78 is equals to n by 2 into 51 minus 3n, 3n square minus 51n plus 156 is equals to 0, and n square will minus 17n plus 52 will be 0. Therefore, n minus 4 and n minus 13 is equals to 0. So the n will be 4 or n will be 13. So the both values of n are admissible. So the number of terms in is either 4 or either 13 forms the sum of 78. So now let's find the sum of the first 1000 positive integers and the first n positive integers. So now let's begin for the first one, that is the first 1000 positive integers. Let's find the first 1000 positive integers. Now let's assume S is equals to 1 plus 2 plus 3 plus so on will be the 1000. Now using the formula, Sn is equals to n by 2 into a plus L, for the sum of the first n terms of an arithmetic progression. So we have S 1000 is equals to 1000 divided by 2, and a will be 1 plus and L will be 1000, which will be 500 into 1001, which is 500, 500. So the sum of, therefore, the sum of first 1000 in positive integers are 500, 500. So now let's find the second, that is the first n positive integers. Now let's assume assume Sn be 1 plus 2 plus 3 plus so on plus n. So here A will be 1 and the last term, that is L, is n. Therefore, Sn is equals to n into 1 plus n by 2. So therefore, the sum of first n positive integers is given by Sn is equals to n into n plus 1 divided by 2. Okay, now let's see the next question. Find the sum of first 24 terms of the list of numbers whose nth term is given by an is equals to 3 plus 2n. So now let's find the sum of first 24 terms of the list of numbers whose nth term is given as an is equals to 3 plus 2n and a1 will be 3 plus 2 is equals to 5 and a2 will be 3 plus 2 into 2 is equals to 7. A3 will be 3 plus 2 into 3, which is 9. So list of numbers becomes list of numbers are 5, 7, 9, and 11 and so on. So here if we see 7 minus 5 is equals to 9 minus 7 is equals to 11 minus 9 is 2 is equals to 2 and so on. So the common difference, that is D, is 2. Hence it forms an arithmetic progression with a common difference D. So let's find out S24. So now let's find out S24, where n will be 24 and A is 5 and D is 2. So S24 will be 24 by 2, 2 into 5 plus 24 minus 1 into 2. We have substituted with the formula, that is Sn is equals to n by 2, 2a plus n minus 1 into d. So 24 by 2 will be 12. 2 into 5 will be 10. plus 24 minus 1 will be 23. 23 into 2 is 46. 12. 10 plus 46 will be 56, and 12 into 56 will be 672. Therefore, sum of first 24 terms is 672. So now let's see the next question. A manufacturer of 20. So now let's see the next question. A manufacturer of TV sets produced 600 sets in the third year and 700 sets in the seventh year. Assuming that the production increases uniformly by a fixed number every year, find the production in the first year, the production in the 10th year, the total production in first 7 years. Let's find the first question, that is the production in the first year. So since the production increases uniformly by a fixed number every year, the number of TV sets manufactured in first, second, and third years will form an arithmetic progression. So let us denote the number of TV sets manufactured in the nth year by AN. Then A3 will be 600 and A7 will be 700. Or we can also write it as A plus 2D will be 600 and A plus 6D will be 700. So let us solve these questions, these equations. That will be 4D is equals to 100. So D will be 100 by 4, where D will be 25. And let us find out the A. A plus 2D is equals to 600. A plus 2D will be 25. 600. A plus 50 is equals to 600. A will be 600 minus 50, that is A is equals to 550. So now we found out the value for D and A. D will be 25 and A value, that the first term will be 550 in the arithmetic progression. So therefore, the production of TV sets in the first year is 550. So now let's find out for the second question, that is the production in the 10th year. So A10 will be A plus 90, whereas A10 is A will be 550 plus 9. D will be 25. 550 plus 225. So the 810 will be 775. So the total production in the 10th year is 775 TV sets. So now let's find for the third question, that is the total production in first 7 years, the total sum of the first 7 years. So Sn will be n by 2 to 2a plus n minus 1 into d. So since it is 7 years, Sn will be 7 by 2, 2 into 550 plus 7 minus 1, and d will be 25. 7 by 2 plus 150, that is 7 minus 1 will be 6. 6 into 25 is 150. So the total for S7 B is 4375. Therefore, the total production of TV sets in the first 7 years is 4375. So now let's see the important topics in this chapter. The three main important topics in this chapter is finding arithmetic progression and finding the nth term of an arithmetic progression and finding the sum of first n terms of an arithmetic progression. So finding arithmetic progression will be for 1 mark. Mostly the questions will be for 1 mark, and the find the nth term of an arithmetic progression, the questions will be in the 2 marks and the 3 marks. And the last topic, that is find the sum of first n terms of an arithmetic progression. The questions will be in 3 marks. So in this video, we completely understood about arithmetic progression. In the upcoming videos, you also have syllabus covered on triangles, circles, and real numbers, etc. So please ensure to subscribe the channel and turn on the post notifications so you don't miss out any important updates. This is Rachana from Road to Success. Thank you.